Okay, let's consider this example here, the integral from minus infinity to infinity of 1 over 1 plus x squared. First and foremost, for us to be able to work these integrals out, this function must be defined for everything. So of course, notice the only thing that could make this undefined is division by 0. But because it is 1 plus x squared, the only time x squared plus 1 would be 0 is if x is equal to plus or minus I, which across the real numbers doesn't happen. So this is defined everywhere across the real numbers. So we break that up, since it's negative infinity to infinity, as the integral from negative infinity to 0 of that 1 plus x squared dx plus the integral from 0 to infinity of 1 over 1 plus x squared dx. Now remember that the integral of 1 over 1 plus x squared dx, you could work this out, but I'm just going to recall that that's just the derivative of the arctangent. That's just the derivative of the arctangent. Okay. So that means that I'm basically going to have two things that I'm going to need to work out. The one to negative infinity to 0, and one from 0 to infinity. So I'm going to work the two of those things out individually, and then I'll put those two ideas back together. Okay. So, integral from negative infinity to 0 of 1 over 1 plus x squared dx. Remember, that is the limit as b goes to negative infinity of that integral, which we know is arctan, evaluated between b and 0. So that would be the limit as b approaches negative infinity of the arctan of 0 minus the arctan of b. Now, to compute this, what happens to arctan of b as b goes to infinity? Okay. What's happening to that? Well, to answer that question, we need to kind of review what the arctan function is doing. What is the arctan function doing here? So, to talk about the arctan function, I'm going to first go back to the basic graph of the tangent function. So I need to understand the basic. To talk about arctan, I need to understand what's going on with the basic tangent function. And the basic tangent function, especially the one that's tied to the arctan, is defined just between negative pi over 2 and pi over 2. I need to fix up my vertical line here. Okay, so I'm going to have here a vertical asymptote down here at pi over 2. It's right now, it's still off a little. That looks about right. Then I'm going to have another one over here at pi over 2. Okay. And then remember what the tangent graph looks like here. So here we are at negative pi over 2 and at pi over 2. On the x-axis, the tangent graph is approaching the 1, is up, kind of levels off towards 0. and then comes again. Now that is the tangent graph. Now remember, what happens with the inverse tan is your x and y's are getting interchanged. Okay, so when we ask arctan of negative infinity, basically what's happening to the arctan as we approach negative infinity. Okay, this is an x value here with the arctan, but in terms of the graph, it would be looking at the y value. What's the y value? So as y goes to negative infinity, what's happening to your x? You're approaching negative pi over 2. So as the limit, as b approaches negative infinity, arctan of b is actually going to approach negative pi over 2. All right, because remember, with the inverse, everything's reversed. So if I'm looking at inverse, the x is the b value. But now on the graph of the tangent, I need to look at what's happening to my y value, though. Okay? And so therefore, as we go to negative infinity, your x value is approaching negative pi over 2. So as we go towards negative infinity here, this is going to be arctan of 0, which is 0 minus a negative pi over 2. So that integral is going to work out to be pi over 2. And then in a similar fashion, the integral from 0 to infinity of 1 over 1 plus x squared dx will be the limit as b approaches infinity of the arctan of x evaluated between 0 and b. That will be limit as b goes to infinity of the arctan of b minus the arctan of 0. As b goes to infinity, when we go back to the tangent graph, instead of looking at x, we look at y. As y goes to infinity, notice that x is approaching pi over 2. So as b goes to infinity of arctan of b, we're actually going to approach pi over 2. And again, arctan of 0 is still just 0. So this is going to be pi over 2 minus 0 equals pi over 2. And so we put our two pieces together, pi over 2 plus pi over 2 is pi. So it turns out the integral from negative infinity to infinity of 1 over 1 plus x squared is actually equal to pi. Okay. And so, therefore, this does actually converge, and it converges to pi. Converges to just pi.